Let's start talking about IP cameras. We can divide those IP cameras from different points of view. One will be from types of lenses and movement. So you can have a static view, or cameras with varifocal lenses, or you can have PTZ camera or fisheye camera. There's more than that, but let's say that the most common. So static view is a camera which has one focal length and that's it. You cannot change it. Then you will have IP cameras with varifocal lenses, where you can move camera from zoom in a little bit or zoom out. Then you can go full PTZ, which is a pan tilt zoom camera, which can move up and down, left and right, and can zoom in and out. Some of them have even zoom optical zooms like 15. Then you have a fisheye camera, which is a distinctive type of view. They're often being used to with one camera show a bigger area, but the picture is distorted. That's why it's called fisheye. It's not. It's mostly to see what is happening in general. Let's say in the office, but it's not. You cannot clearly identify certain things because the picture is distorted. Has a certain shape. Then you can divide them by resolution. As I said, at the HD cameras, IP cameras, they don't use old analog resolutions. There's no such a IP camera. I didn't see at least those cameras. You can have the minimum you can have is 1 megapixel, which is 720p, which is 1280 by 720. Then you have 2 megapixel, 3 megapixel, 4, 5, 8, which is 4K Ultra HD cameras. That's 8 megapixels. And the good thing about IP cameras in the resolution is that you can log into the camera and change the resolution. So you can buy, let's say they have an older NVR which cannot handle more than 2 megapixels, but you can buy better cameras. First, because you can stream them somewhere else individually, and also because you can one day upgrade your NVR. Let's say you're planning that in next year you're upgrading NVR, so this year you're upgrading cameras. So you can upgrade your cameras, change the settings in the camera to maximum what that NVR can handle, which in that case would be 2 megapixels. And then when you upgrade your NVR, you can upgrade your cameras just by logging into them. So that's a good thing. You can divide them by shape. You have a dome camera, you have a bullet, C-mount, covered. Dome, it's obvious. Bullet also is obvious. Dome cameras usually are used internally. Bullet usually externally. C-mount, they're not that common anymore because most of the cameras come with lenses. But C-mount is type is that you can install your own lenses on the camera. And sometimes it's possible with some cameras, but as I said, most of cameras come with the lenses already. Covered, it's a small camera which you can hide somewhere. Nobody can see where it is, but you are recording. Then you can divide them by connection type. So most of cameras would be wired, but then with IP cameras there's no reason why you cannot have wires. You just need a transmitter, and which you can transmit your network from the camera. But then you will need obviously power supply for the camera. Then you have let's call it special type of cameras. One I already mentioned, which was fisheye. But then, for instance, you have an ID camera. An ID camera is just regular camera, which has two outputs. One is for the DVR and one is for the monitor. And what it does, you place it close to the entrance, and when somebody enters, let's say they're often used in a retail. So when somebody enters, it's automatically displayed on the monitor so they can see themselves. It's deterrent. And typically the camera will have analog and HD output, and analog is used for the monitor and HD is used for the DVR. Then you have that PTZ, I already mentioned that, which is pan, tilt, zoom, which can move in basically every direction, can spin around, and can zoom in and zoom out. It can have also some other special functions like following people, being triggered by some events, alarms, and so on. ANPR is automatic number plate recognition. It's a camera which basically takes a picture of the registration plates of the vehicle. Other cameras can do some other intelligent functions like people counting or crossing certain line or something like that, or object disappearing or object appearing in the field of view. Here you can see the dome camera on the left and the bullet camera on the right. One thing you may notice, here you see the junction box, and the same here. Those cameras come with the short cables. And depending on where they are fitted, you can make connections inside the wall, but a lot of times you have to fit it on the junction box. You can buy some different junction boxes, but you can order junction box with the camera from the same producer, so the screws will fit in easily. Here you have an example of the PTZ camera. It's an old camera, but shapes of housing are very similar. And in such a camera you have typically you have a power cable, you have data, and you have a picture cable. These are old housings for old analog cameras. In modern cameras you don't use those housings, you use the cameras like that. But you will see a lot of those. I can see a lot of those cameras in Ireland, and in the UK probably would be no different. Thank you. Hi. Let's talk about IP camera quality. The main element of the quality will be resolution, and we already discussed it a few times at different occasions. So these are IP camera resolutions typical, which you can buy from 1 megapixel to 8 megapixel. And as you remember from that shopping center picture, you will see how much you can gain by using higher resolutions. The next part of the IP camera quality is compression. So the higher the resolution, the more data is required to be sent over the cable. So the higher the compression you need to fit it on the DVR on some smaller hard drive. If you would use the H.264 compression and 8 megapixel camera, I didn't count, but you will require huge hard drives, and I mean huge. But if you go from 264 to 265, you will get much better compression, and then if you go even higher to 65 plus, you will get huge savings on the hard drives. So to H.264, it's called Advanced Video Coding, and it's the most commonly used format in CCTV, also being used by YouTube and Vimeo. H.265 is called high efficiency and can save up to 30%. Then if you would use H.265 with the smart and AVBR technologies, you can save up to 50% in comparison with the H.265. If you, for instance, if you are using M8 megapixel cameras, I'm sure you would have to use H.265 plus. Then obviously, as I mentioned before on a couple of occasions, when you're picking that type of cameras, you have to make sure that your NVR can handle that, unless you want to kind of downgrade inside the camera, so in the settings of the camera change to smaller resolution. Another part of the quality are frames per second. So if you would use 30 frames per second, it's a movie quality, completely fluent. Like if you're watching TV, movies, 25, 30, it's a quality, it's a movie quality. So if you use any of those, it's perfect. But for CCTV, it's enough that you use somewhere around 15 to 7, and it's still pretty fluent. And the difference between 15 and 7 is difficult to notice. But if you go below 7 frames per second, it's a low quality, it shouldn't be really used. Bitrate. Bitrate, it's a measure of the amount of data that is moved from one point to another. And bandwidth required for the security camera is around, with a compression H.264, it's for 1 megapixel is 2 megabits per second, for 2 megapixel is 4 megabits per second, and for 4 megapixel camera is 8 megabits per second. As you can see, all those values here are below the lowest capability of the Cat5 cable, which is from 10 megabits per second to 100. So even that camera should be Cat5 should be able to handle that. After that, you should use Cat5e. And how you calculate? So you have an IP camera bandwidth calculation formula. You have a bandwidth in megabits per second. So it's as you remember, we for both cameras we're setting for each camera we're setting mainstream and a substream. So you take a bitrate from the mainstream. As you remember, I was in those settings setting I think 2000, around 2000 I think 48, and you multiply by the number of cameras, and then you add the substream, which was I think 1024, also multiplied by the number of cameras, and you add them together, and this will give you a required bitrate. Thank you. IP camera programming. It will be similar like in the NVR. First of all, you have two options. You program it from the screen. Sorry, you don't have two options. You have one option. You connect to the camera over the network. You have two options with the NVR. But sometimes you have two options, because you could use the so-called tools, which is software provided by the producer of the camera, and you can kind of log into the camera from that software. But most of the time, the way I do this is I connect a laptop to the same range, IP range, and I program camera from the laptop, because this gives me much better control of what I'm setting. So as usual, you set up your secure password, and a lot of producers will require at least 8 characters, 1 capital letter, 1 digit, at least 1 digit, 1 capital letter, and 1 special character, something like that. I'm not saying this exactly the same, but more or less. Again, with the IP cameras, it's extremely important to set up proper date and time, and do not forget the time zone, and then daylight savings time and network time protocol. Again, follow guidance for your country. Why it is important? Because for many IP cameras, if you won't set properly that, you leave it alone, what happens? Camera will stay in the time zone from the producer, which a lot of them will be China, and a lot of IP cameras display their own time on the new NVR screen. So then you have some weird situations where main time of the NVR is, I don't know, 5 o'clock, and the camera is like 8 hours off. And then you have to log into every camera. I had so many such cases that whoever was installing that was doing a really bad job, and they wouldn't change the time zone. They would change the time, but not the time zone. And certain whatever, somebody won't notice that, and then they will notice, and they have to call back and change it. And you are lucky if you remember, you know the password for the camera. So anyway, password, and then complete setup of time, including time zone, daylight savings, and network time protocol. I didn't say what the network time protocol is, but it's basically address where the camera can synchronize the time. It's important, and typically I set it for 60 minutes. So camera every 60 minutes can connect and synchronize the time. Then you set up your office network, IP address, subnet mask, and gateway. If you know them, if you don't know them, follow steps about settings IP. The next slide. In most cases, your camera will have all the ports already set, default ports. Do not change them at this stage unless you really know what you're doing. Make note of all the ports and IP. IP setup. If you know all the IP addresses already in use, just pick one that is free. If you do not know what is in use, to initially find your IP address, subnet, type ipconfig in a CMD on a computer laptop, which is already connected to the network. Run IP scanner software. I will have also a lesson on that. It's probably not today yet, but I will. It's called Advanced IP Scanner. You can install it, and it will let you discover all the devices on your network. And then you can pick the address which is free. Another way to get a proper IP address is to set camera to DHCP. I already explained in another lesson what DHCP is. So you check that box, you connect camera to the network, and let camera run its course, and it will obtain IP from the network. When it is all done, the camera has already IP mask and a gateway. You untick the box and click Save Apply. You do not want to leave your camera on DHCP, Dynamic Host Configuration Protocol, as it may create connectivity problems with external access, or actually with camera we may create problem with access for the NVR. Oh, sorry. Thank you.